Okay, and we're continuing with question 6 and question 7 from this iGCSE paper 4. Before I get started, again, please do press that like button. That really helps the video spread across the YouTube world, and hopefully that will help other people improve on their iGCSE paper 4 skills. Okay, and on to question 6. So Piero invests $5,000 in Bank A and $5,000 in Bank B. Very sensible. Splitting the investment. So Bank A pays simple interest, so let's highlight that, simple interest, at a rate of 6.5% per year, and find the total amount that Piero has in Bank A at the end of the 4 years. So the key things to take into account here is we want the total amount at the end, and we're doing simple interest. So simple interest means the interest doesn't change from year to year, so the interest stays the same every year. So something to take into account. So the way we calculate this is we can do this in one simple calculation. So our total will be 5,000. So we start with the $5,000, and then we need to work out 6.5% of 5,000. So that's going to be 0.065. Remember, to go from a percentage to a decimal, we divide by 100, and then we're going to times that by the 5,000 here, and now we want this over 4 years, so then we multiply that by 4. So this calculation here gives us the interest, and then this calculation, adding this to the 5,000, gives us the total amount. So let's go over to my GDC and work this out. And if we put this into our calculator, as you can see here, we get our final answer of $6,300. This second part of the formula we're going to use in the very last part of the question as well. So we write in $6,300 for our 3 marks. And now we need to find the number of complete years it takes for the total amount that Piero has in Bank A to be greater than 10,000. Now you can do this using an algebraic approach. What I've done with my students, usually at iGCSE level, is do a trial and error approach. So notice after 4 years, we get 6,300, and we want to get a figure greater than 10,000. So what I do here is set up this trial and error approach. So the calculation we're going to do is this, and all we're going to change is this number here. So times 5,000, and then the key thing here is to change this number, the number of years. So we're going to try out 10 to start with, and let's see what we get. Okay, so after 10 years we get 8,250, which is again not quite 10,000. What you can do with the graphical calculator is you can actually copy and paste. So that's really helpful. So I'm just going to paste this across, and this time I'm going to change this to say 12 years. That gives us 8,900, which is again not quite enough. So I'm going to use the copy and paste function. You can do Control V and Control C on your graphical calculator. Let's try say 15 years. Okay, this is really close, so 9,875. So let's try the year above that, let's try 16 years. And you'll see we get to our answer above the 10,000 here. So what we need to do is write this part here, this calculation. Now I can actually use my calculator here and copy this calculation across. So of course you'd write this in the exam, but hey, I've got a graphical calculator, I'm going to use it. So I'm going to pop this across to show my working. Notice we've got that transition from 15 years to 16 years, which then gives us our final answer. So we know we need the 16th year in order to go beyond 10,000, so 16 years. I'd also write the answer from your calculator here as well. Okay, and now we're going to look at some compound interest. This is where the interest changes year on year. And this formula that you need to know. So you need to know this off by heart, because this will give you 2 or 3 marks in the exam. So to work out the total amount, so go total, this is equal to the original times the multiplier, I will talk about that in a moment, to the power of the number of years. So you need to know this formula. This is not on your formula sheet. So we put in the information we have. Well, the original amount was also 5,000, so we put in 5,000 here. Now the multiplier, well, we're increasing by 4% each year. So if we take 100% plus 4%, well, that gives us 104%. And now we, again, like the previous question, we want to change the percentage into a decimal. So we divide by 100, and that gives us 1.04. So that is our multiplier, and then the number of years in this question is 4. So we put 4 here, and now this is a case of just putting this into your graphical calculator. So we have 5,000 multiplied, open brackets, 1.04 to the power of, so make sure you know this button where it is, to the power of 4, and then we generate our answer, and generally they want the answer to the nearest cent, so we want $5,849.29, which I've written here as well. And the next question is find the number of complete years it will take for the total amount that Piero has in bank B to be greater than 10,000. And the reason I use this trial and error approach is it works for simple interest as it does for compound interest too. So I'm going to copy this formula across. Again, I'm going to leave this 4, like last time, kind of blank, so we can work out some possible answers. So notice the formula starts the same, it's just I'm going to put in different numbers here and try out what could work. So again, we'll start with 10, that seems a reasonable number to try, and let's see if we can get close to the answer that we need. Okay, so you see the answer here by putting in 10, we only get $7,401.22. Again, I'm going to use this nice trick that I can use here of copying and pasting. So 10 didn't seem to be enough, so let's go up to 15. Let's see if that has an effect. We get 9,004, getting closer. Let's try a higher number. Let's try 18. Let's see how we get. And we're just doing this trial and error approach. Okay, that goes beyond the 10,000. So we need to go a little bit below just to see in case 17 works. So you can just try this trial and error. Okay, 17 is not quite 10,000, so you know the answer will be 18. Again, I'm going to copy it across this information. And I'd recommend when you're doing this process to actually write these steps out as you go along. I had the benefit here of copying and pasting directly, but this process shows the examiner you've tried different answers here to get to our answer of 18. So I'm going to pop in 18 years. An effective strategy at this level, again, when you get to IB or A level, you'll need to use a more algebraic approach. And part C, by sketching suitable graphs, find the number of complete years it will take for the total amount that Piero has in bank B to be greater than the total amount in bank A. So notice, in this answer here, it took 18 years to get to 10,000, whereas in the previous question here, it took only 16 years to get to 10,000. We need to model this approach. So what we're going to do here is actually take this part of the equation here, and for the other part, we're going to take this aspect of the two models that we've looked at. So let's start with the compounding bank B first. So with bank B, we're going to take the increase of 1.04 to the power of x. Okay, so we want to work out the number of years. Now notice we don't need to worry about the 5,000. We're going to make sure both models start at the same point, and you'll see that on the GDC. With bank A, this is a bit more complicated. We're going to have a look at our model, so it's this section here. So again, we're not going to have to worry about starting at 5,000, so we just need the percentage of simple interest and times by the number of years. So we're going to focus on the 0.065 times by x, the number of years. Now we want both models to start at the same point, so I'm going to add a 1 on here, because notice when x is equal to 0, so let me just show this process. When x is equal to 0, well 1.4 to the power of 0 is equal to 1. When x is 0 here, then the model is equal to 1. So we have the same starting point for both models, just like if you started at 5,000. It's going to make the maths a little bit easier. So what we're going to do is we're going to take both models, we're going to take Bank B's model and Bank A's model, and we're going to put it into our GDC. Okay, so you're going to need the add graph section of your calculator. Make sure this is always set to degrees, by the way. It's not going to matter for this question. So we're going to put in Bank B's model, so that's 1.04 to the power of x. Now don't worry if you don't see anything on the board. We do in this case, and we're going to put in the Bank A model. So Bank A's model was 1 plus 0.065x. And notice we get two functions on the board. Now notice they both start at the same point, so they both start at 1. And what we want to find is when actually the blue model becomes bigger than the red model in this case. And notice we can't see that directly. There's a couple of ways we can fix this. So I'm going to use the window zoom out button here. And notice I'm going to zoom out until they both cross. Now we still can't see really what's going on too well. So we can also use a function called zoom fit, which is also very helpful. And this is a much easier way of seeing what's happening to the two functions. So remember, the red model represents the simple interest. The blue model here represents the compound interest model. And you'll see they start at 1. They both start at 1 here, but they also cross over here too. Now, this is not necessary, I don't think, for the question, but we can find out that intersection point by analyze graph and intersection. We click before, click after, and you'll see after 23.9, so after 23.9 years, that the two models will then be at the same amount again, and then the blue model then goes up and up and up much more quickly. So all I'm going to do, this is in the exam, you'd obviously sketch all the information you see in front of you here. I have the benefit, of course, of using a screenshot, so I'm going to put the screenshot into the PowerPoint here, but this is exactly what they will expect. So you can get all this information from your graphical calculator, you can see the two models, you can see the intersection point. So the complete years, of course, 23.9 years is not complete, so we need to put in 24 years, rounding upwards. And that's all you need to do for this style of question. Again, it's an A-style question and really trying to push your understanding of percentage calculations and applying that using your GDC as well. Okay, and the mark scheme, so you can see all the answers that I've given already and also on here as well. Weirdly, in the mark scheme, they don't actually give the final answer here, which is 24, but that is the answer to this. But you do need this correct sketch in here as well. That's really, really important. And on to question 7, which is a little bit untypical for a paper 4, more in the style of a paper 2, where we're going to solve a series of equation questions. So we're going to solve the simultaneous equations here, and we need to show all our working. So you can't just try and use any equation solver or linsolve. It should be blocked anyway, but you do need to show your working. So with this question here, we want to try and make the y's the same. That's our strat here, our strategy. So the way we do this, we're going to times the top equation by 3 and the bottom equation by 2. So let's work out what we get. So if we times everything here by 3, or 7x times 3 is 21x, 2y times 3 is plus 6y, 8 times 3 is equal to 24, don't forget the right hand side, and then this equation, 2x times 2 is 4x, minus 3y times 2 is minus 6y, and then 13 times 2 is 26. Now because these symbols are different, we're going to add the two equations together, because notice 6y plus minus 6y, that's going to equal to 0. So 21x plus 4x is 25x. As we just said, 6y plus minus 6y is equal to 0. That disappears. And then 24 plus 26 is equal to 50. You can check any of these calculations on the calculator. Now we want x on its own. So what's the opposite of timesing by 25? We divide by 25 on both sides. This cancels here, and we're left with x. And then 50 divided by 25 is equal to 2. Now don't celebrate at this point, because we need to work out what y is as well. I generally go with the equation that's got the most positives in it. So I'm going to call this equation 1 here. And now we're going to sub in equation 1. So wherever I see an x, I'm going to put a 2. So 7 times 2, that's equal to 14. I'm going to keep everything else the same. And now we just got some equation solving to do here. So we want to get the y on its own. So what's the opposite of plus 14? Well, that's minus 14 on both sides. This cancels. We're left with 2y is equal to, well, 8 minus 4 is equal to minus 6. And then finally, what's the opposite of times it by 2? We divide by 2 on both sides. And this gives us our final answer of y is equal to negative. So x will be equal to 2 and y is equal to negative 3. And now they test your equation solving skills in some slightly different contexts. So we just need to stick to the same method we used before. So 3x minus 4 is equal to minus 19. Again, we keep chipping away at the equation until we get x on its own. So what's the opposite of minusing 4? Well, we add 4 on both sides. So this cancels here, leaving us with 3x. Minus 19 plus 4 is equal to minus 15. Know your negative numbers. And then what's the opposite of timesing by 3? Well, divide by 3 on both sides, leaving us with the answer of minus 15 divided by 3 is equal to minus. Just showing clear working, making sure you take your time is really important with these questions. On this question here, well, we've got 15 minus 5x equals 7 minus 3x. Now, my general strategy when x's are on both sides is to find the least amount of x. So that's here minus 5, because minus 5 is less than minus 3, and then do the opposite operation. So what's the opposite of minus 5x? Well, that's plus 5x on both sides. This cancels here. That's the idea. So we're left with 15. 7 stays the same because it's just a number. And then minus 3x plus 5x is equal to plus 2x. Careful with negatives as always. And then we want to get the x on its own. So the opposite of plus 7, minus 7, both sides. 15 minus 7 is equal to 8. This cancels. Very convenient. And you probably can see the answer at this point. So we're going to divide by 2 on both sides. And so x, because this cancels, is equal to 4. This is a nice question. You're going to get 8 marks here from the simultaneous equation before and this, just for some relatively straightforward equation solving. And this question is looks a little bit weird, but again, we just approach it in the same way we've looked at the previous questions. Let me write this out a little bigger for you. And our general strategy here, when we have a fraction, we want to remove it as quickly as possible. So what's the opposite of dividing by x plus 1? Well, we're going to multiply by x plus 1. Again, on both sides of the equation. So if we do this, this cancels. That's very helpful. We're left with 28. Then we've got minus 4, open brackets, x plus 1. Now you could expand brackets here and then simplify, but there is a quicker approach here. Remember, these two things are just times together. So what's the opposite of timesing by minus 4? Well, we can actually divide by minus 4 on both sides. So 28 divided by minus 4 is equal to minus 7. Very conveniently, this cancels, leaving us with just x plus 1. And then to get x on its own, well, what's the opposite of adding 1 or minusing 1? And just be very careful with negatives here. Get x on the right-hand side, and minus 7 minus 1 is equal to minus 8. So just be very careful. Don't put minus 6. Please don't do that in the exam. Make sure you get that final answer of minus 8. And what they've done here now is they've actually added a log question in, which is a little bit strange. I haven't seen this on a paper 4 before, but there's no reason why not. So now we've got a log expression, and we need to find x in terms of p and q. And whenever you get a simplifying log question at iGCSE, your strategy here, I'm going to write this down because it's really important, is you want to get the equations in such a way that you get log something equals log something. Once you have that, then you can remove the logs from both sides. And the mistake that people often make here is they try and cancel logs here all the way through, and you get totally the wrong answer. So please don't do that at home. Right, so we're going to simplify this. Now, the first rule that we're going to use is we're going to use the log rule number 3, I call it, the power rule. So we can bring the 3 to the back. That's the first thing I'm going to do. So I'm going to do this in very clear stages. So logs allow us to do this. So we get log p cubed minus log q minus log 8. And again, we can do the same thing on the right-hand side. We can take this 2 and bring it to the back. So that gives us log x squared. And we're going to use our log laws slowly but surely to make sure we get log something equals log something. Our next log law is when we're minusing logs, it's the same as dividing. So that means we get log p cubed divided by q minus log 8 is equal to log x squared. Doing this one step at a time. So remember, when you're minusing logs, it's the same as dividing what's inside the log. And the same rule applies for the next part. So when we're minusing logs, it's the same as dividing. So we get log p cubed over 8q. So the 8 goes in the denominator, is equal to log x squared. And we're almost there. So now we've got it in this log something equals log something form. Only at this point can you cancel logs. Okay, what you're officially doing here is raising 10 to the power of. but it has this effect. So now we get p cubed over 8q is equal to x squared. And at this point we want x on its own. So what's the opposite of squaring something? Well, we want to square root both sides. And if we do that, this cancels. Let me pop this over here. So x equals, and then we want the square root of all of this. So the square root of p cubed over, which we write into our answer box like so. So make sure you're happy with that particular process, because it's quite a tricky log question for iGCSE standard. Make sure you go through each of the steps here as well. Okay, that's very important. So you can see the answers for the various different questions that we've gone through. Just be very careful your negative numbers when looking at these kind of questions. If you want to check out any more paper 4 videos, then please look at the 2 videos in front of you. So it goes through a walkthrough I did before and this current walkthrough as well. See you on the next video.